This will give us 4 seconds going up, 1 1000, 2 1000, 3 1004, and 4 seconds to go down, 1 1000, 2 1000, 3 1004. Today's question is from Haley, who's trying to take her Logix Pro exercises and put them into a ControlLogix PLC. By the way, Haley, that is an awesome test setup you have. But the one thing she doesn't have is a high-speed counter to track her encoder pulses of the elevator as it goes up and down. We could do this with some basic logic in our main routine, but I thought this was a good opportunity to learn about periodic tasks. Most of the programming we've been doing has been in this main routine right here, which is under this main program and this main task. And if we right-click this main task, we see that it is a continuous task. Now it's going to run absolutely as fast as it can, like ridiculously fast, which sounds like what you would need for most programs. But the thing about it is its task time can expand and contract depending on what you're doing that particular scan cycle. A periodic task is going to fire exactly every X amount of milliseconds. So you're going to get a very repeatable result. So you'll see this used in things such as PIDs. And also, probably an argument can be made that most of our programs should be in something like this. What we're going to do is we're going to right-click task and get a new task. And I'm going to call this my elevator encoder. And it's going to be a periodic task. Now the task time, at least initially, I'm going to put this at 16 milliseconds. And unlike our main task, notice there's no arrow by the elevator encoder. So we have to build out this entire structure that's normally done when we create a new program. So we're going to right-click it, add new program, and this will just be our elevator program. And if we open it up, we notice there's no routine. So we're going to right-click elevator program, add new routine, and this is going to be a ladder diagram. I'll call it elevator routine. Now in Haley's case, with the drum retracted all the way, which is the elevator at the top floor, that's 0. And actually there's a little extra space. So 45 units is 0. And then all the way at the bottom floor is 255. So she needs, when the elevator is going up, for it to subtract numbers, and when it's going down, to add numbers. So let's right-click controller tags, new tag, and this will be elevator up, and it's going to be a Boolean tag. And then let's create one that's elevator down, and it's going to be a Boolean tag. Then let's create one that's called elevator position. Now I'm going to bring down and examine on, and I'm going to go over to my compute math tab and bring down a subtract. And so for subtracting, we're going to be going up. So elevator up, and we are going to subtract elevator position. We're going to subtract 1, and we're going to put it in the destination of elevator positions. So that means every time this periodic task fires and our elevator up is happening, we're going to subtract 1. Now we only want to do that until we get to a value of 45. So I'm going to go to my compare tab and put a greater than, and we're going to look at this elevator position as long as it is greater than 45. Now we're going to do the almost exact same thing. We're going to bring it on a new rung. We're going to go and bring down an examine on. And this time we are going to be looking for it to be less than a value. And we are going to add a value. And this one here is going to be elevator down. This will still be elevator position. And the max position when going down was 255. And we'll put that elevator position into source A and the destination. And source B is going to be a 1. let's put this in our PLC and see how this part works. And if you need any help downloading your program or configuring your drivers, or I went too fast through creating programs or any of that, just look down in the description. We have lessons on all of that. And if we've done this right, we should be able to right-click the elevator down and toggle this bit. And when we do, it should take about 4 seconds for the elevator position to get to 255. So 1 1000, 2 1000, 3 1000, 4 1000. All right, that's roughly what you needed. And we can toggle that off. And then we can toggle the elevator up in 1 1000, 2 1000, 3 1000, 4 1000. So yeah, that gives us about a 4-second travel time between the up and the down position. This gets us through the basics. What if we wanted to speed up and slow down the elevator? We can actually change this periodic task rate. Haley told me she wanted her encoder to increment every 16 milliseconds. But let's use a compute statement and vary it based off of how long we want it to run from the bottom value to the top value. First, let's change these source B's from fixed numbers to tags. So let's edit the elevator up one, and this will be elevator up max position. And we'll go ahead and create that, and it will be a double integer. Then let's create elevator down max position. Create it. It will also be a double integer. And go ahead and put a value back in just like it was. So this one here was 45, and this one here was 255. And now let's go to our main routine, which is in our main task, and let's bring down a rung and go to our compute math tab and bring down a compute statement. And let's right click our controller tags, new, and this is going to be our task time. This is where we're going to put this at, and it will be a double integer. And then let's right click new tag. This is going to be our elevator total time. So this will be the total time it takes from the top to the bottom. We'll go ahead and create it as a double integer. One thing I just thought about is I created that as a double integer. It can only handle whole increments, 1 second, 2 second, 3 second. You could also make it a real if you wanted the up-down time to be like 3.5 seconds. And now we're going to put an expression in. We're going to put elevator total time. And I want to enter that in seconds, but our task time is actually in microseconds. So it's going to be that times 1 million divided by our elevator down max position minus our elevator up max position. And we're going to put that in our task time. Now I'm just going to put this in here. It's not going to do anything, but I want to make sure that I actually have these numbers close to right before we do anything crazy. So our elevator total time, we need to enter something at. So let's monitor it, and let's put in a value of 4. And that should give us about 19 milliseconds. Okay, and that's roughly it. And yeah, it's 19,000 microseconds. So now we're going to bring down another rung, and we're going to bring down an SSV, which you can just type SSV, and that'll bring that down. And then for our class name, we want task. For our instance name, we want our elevator encoder. And for our attribute, we want our rate. And our source is going to be this task time. And we're going to put that in there. Now if we go to our elevator routine, it should work almost the same. Oops, I still need to finalize these edits over here. We're at our max down position, so elevator up, 1 1000, 2 1000, 3 1000, 4. So about the same amount of time. But now let's go over here to our main routine, and let's change our total elevator time. Let's make it 8. Now if I go back there, I'm going to toggle elevator down, 1 1000, 2 1000, 3 1000, 4 1000, 5 1000, 6 1000, 7 1000, 8 1000. So now it takes about 8 seconds. Haley had a great control logic setup that really even made me drool. But you don't need a desktop control logic setup to learn Studio 5000. You can do it with a basic Compact Logix L16. And you can click here to check out our PLC trainers.